Hi, Mr. Green here. I'm going to take you through the next section of the forces part of the AQA Physics GCSE. This lesson will focus on terminal velocity and your learning objective will be to explain terminal velocity. Please pause the video and write that as your lesson objective. Okay, so retrieval questions to start with. We've got 5 questions. Please answer and pause the video, answer those, and unpause when you'd like the answers. Okay, so question 1. What links speed, acceleration and time? Acceleration is change in speed divided by time. Units for speed and velocity are both in meters per second. What's the difference between vector and a scalar quantity? A scalar quantity's got size only, whereas a vector quantity has size and direction. Is speed a scalar or a vector quantity? Speed is a scalar quantity, it does not have direction. And name another vector quantity. You can have force, displacement, velocity or acceleration. Okay, our learning outcomes today are to define terminal velocity and to describe and explain how the forces and the motion of the skydiver change throughout the skydive. So Felix Baumgartner broke lots of world records on the 14th of October 22 because he jumped out of a massive hot air balloon that had reached a height of 24 miles. So he was 24 miles above the surface of the Earth when he dropped down. He fell for a total time of 9 minutes and 3 seconds. Okay? Now while he was falling, he reached a maximum speed of 833.9 miles per hour. Speed of sound is 768 at sea level, so Felix managed to travel faster than the speed of sound and is the first skydiver ever to do this. But how did he do it, and what was happening to him? In the absence of air resistance, all objects fall at the same rate regardless of their mass. So no matter how much an object weighs, it will fall at the same acceleration. So near Earth, the rate of acceleration of free fall is 10 meters per second. Every second, the speed would increase by 10 meters per second. Due to Earth's gravity, the speed of an object dropped from a height increases at that rate, 10 meters per second every second it falls. And if there was no air resistance, a feather and a hammer dropped would fall at the same rate. If you drop them from the same height, they'd hit the ground at the same time and both travelling at the same speed. Now, terminal velocity is the maximum speed of an object reached when the forces moving the object are balanced by frictional forces. Because we don't live in an area where there is no air resistance will affect the speed at which objects fall on the Earth. When we're talking about it falling at an acceleration of 10 meters per second squared, that's without any frictional forces. Objects falling through a fluid eventually reach a terminal velocity. And at terminal velocity, the object moves at a steady speed in a constant direction, because the resultant force that acts on it is zero. It's not speeding up, it's not slowing down. So a skydiver falling spread eagled through the air reaches a maximum speed of around 53 meters per second. That would be their terminal velocity. So what happens to a skydiver after he jumps out? Immediately after the skydiver jumps out, the force of gravity causes a rapid acceleration downwards. The skydiver's just jumped out of the plane, so there's no air resistance acting on them. So as a result, acceleration's large. The force pulling them down is much greater than any opposing force, so they'll accelerate really quickly downwards. After a few seconds, air resistance increases. The skydiver is still accelerating, but the rate decreases. Because they're falling, they're now encountering air particles when they fall, and the more they fall, the more air particles they encounter. This increases the air resistance. This means the force pulling them down, that doesn't reduce, that stays the same, but the force pushing up increases, so the overall resultant force pulling them down gets lower. The skydiver is still accelerating, but at a much slower rate. Eventually, if they're falling for long enough, the size of the force provided by air resistance becomes the same size as the force of the skydiver's weight pulling them down. The force pulling down and pushing up are equal and balanced, which means the skydiver then travels at a constant speed. We call this the skydiver's terminal velocity. Can't accelerate anymore. However, when the parachute opens, air resistance increases rapidly. So the force pushing up is much higher than the force pushing down. The size of the parachute means the skydiver encounters more air particles, increasing the air resistance. It's like applying the brakes to a car. The skydiver suddenly decelerates. They don't suddenly jump up, they just suddenly start to fall a lot slower. And that's because the air resistance force pushing up is much bigger than the force pushing down, so that decelerates the skydiver. A few moments later, air resistance equals gravity, and a second terminal velocity has been reached at a much slower speed. This is because the skydiver's speed is now decreasing. He's encountering fewer air particles on his descent towards the ground because he's slowed down so much. So that decreases until the air resistance is equal to the skydiver's weight, and that reaches a new lower terminal velocity. Okay, 4 questions for you to answer there. If you could pause the video and answer those 4 questions. Okay, question 1. Correct answer is weight and gravity, which acts downwards, and air resistance acts upwards. Forces after they jump. Immediately after he jumps, the force of gravity causes rapid acceleration downwards. What happens to the forces as he accelerates? As he accelerates, air resistance increases. The skydiver is still accelerating, but the rate of acceleration decreases. When forces are balanced, the skydiver travels at a constant speed and has reached a terminal velocity. Okay, 3 more questions there. Pause the video and attempt those questions. Okay, so what happens to the forces when the parachute opens? When the parachute opens, air resistance increases rapidly, and that causes the skydiver to decelerate. What happens to the forces a few moments after it opens? A few moments later, air resistance equals the force of gravity. Again, because he's slowed down, he's encountering fewer air particles, so a new terminal velocity has been reached. What happens when he hits the ground, though? When he hits the ground, there's rapid deceleration due to the counterforce of the Earth, so the skydiver's velocity becomes 0. Okay, final task for you to do here. I've put a velocity time graph on the board there showing the skydiver's journey. We've labelled those 1, 2, 3, 4, 5 and 6. Copy this graph in your books, label parts 1 to 6 to explain what's happening to the skydiver at those times, okay? So pause the video, copy that down and fill in your answers. Okay, so number 1. The speed increases. At part 2, there's less acceleration because air resistance has increased. At part 3, the terminal velocity has been reached. We can see that from the flat line on the graph. Velocity is constant. At 4, his parachute's open, so the diver starts to slow down. At 5, we're straight again, so a new lower terminal velocity has been reached. And finally, at 6, the skydiver has hit the ground, his velocity has reached 0. Okay, please subscribe to our YouTube channel and check for updates all the time. We're putting new videos on all the time on here. I hope this was useful for you. Please have a look at any of the other videos on there to help you out. Thanks a lot. See you soon. Goodbye.